Hey everyone, Mr. Newman here, just going to show you guys how to do combining like terms and what that means, and also how to solve an equation when there's a variable on both sides. So I'm going to get started with fruit again. Let's say you have 3 pears, 2 apples, an orange, 2 apples, and 2 pears. And I don't know, you got this fruit from all over, so that's why you counted it that way. Well, when you want to count how many pears you have, you don't add the pears to the apples, you add the pears to the pears. And when you want to count how many apples you have, you add the apples to the apples. That's exactly what mathematicians do. We just write shorthand for this. We just use variables because 3p means you have 3 p's in that, okay? 3 pairs, for example. So I'm going to circle the 3p and the 2p, and when you add that together, you get 5p, or 5 pairs. You might not have colored pencils or colored markers that you're doing these notes with, so instead of doing circling the A's, what I would recommend is that you put a box around it just because it's different than the circles, and that can help you distinguish which terms go with which. So we've got 2a plus 2a, and that gives us 4a, and the r we can put into a different, maybe a triangle, and there's only one of those, but you notice I did that just so that I see I've got every single type of variable or constant covered, okay? Now let's pause here and talk about these words I'm using, terms, okay? On the top there are 5 terms. A term is a group of numbers that are multiplied or divided with each other and are separated from other terms by addition or subtraction. So you can count the terms there, 1, 2, 3, 4, 5, and you can see pretty clearly that when you combine like terms that you get fewer terms. So we have 3 terms on the bottom there, 1, 2, and 3, okay? Now like terms are just terms that have the same variables on them but different coefficients, so let's define that. You guys know variables are letters used to represent numbers or be placeholders for numbers, while coefficients are the numbers in front of variables. So the coefficient of p is 5 here, and the coefficient of a is 4. R does not have a coefficient, but its hidden coefficient is 1. Anytime you don't see a number in front, it means there's just a 1 in front of it. And again, mathematicians are too lazy to write 1 orange, we just want to say orange. So those are variables and coefficients, and like variables, or like terms, sorry, are ones where the variables are the same. And if there's no variable, we call that a constant. You'll see that in a second. Those are also like terms. So let's try a problem down here. Oh yeah, one thing we do is we say we just simplified that. So we'll do some of those practices in class, but then we'll quickly move to solving equations. So I'm going to circle my like terms. You notice I circled everything with an X on it, and then, very important, I circled the negative in front of the 11, and also circled the positive in front of the 3. You add those two together, you get negative 11 plus 3 is negative 8, so that's going to be negative 8x. Let me put a box around the negative 4 and the positive 2, and go ahead and mark down. Notice the signs go with the numbers, okay? And negative 4 plus 2 is negative 2, and that equals negative 26. Now one thing that's a little confusing for some students, I'm using minus 4 and negative 4 interchangeably. When you're combining like terms, those two things are the same thing, negative 4 and minus 4. So it's okay whichever one you think of it. I prefer to think of it as negative 4 because I can add that much more easily to positive 2. So now you see we just have a 2-step equation that we all know how to solve. So we add 2 to both sides, get negative 8x equals negative 24. Divide by negative 8, and you get, you get you get positive 3, okay? So that's how you solve these problems. Let's go through and look at a few examples here. We'll start this one off together. 9d and negative 2d, we're going to circle that, and that becomes 7d. I'm going to put a box around the 4, because that becomes positive 4, and that equals 32. So I'll let you solve the rest of this one. Go ahead, pause it, and finish solving, and answer this question. All right, next up, I'm going to start the next one off just by circling those terms for you, and boxing the negative 3, but I really want you to combine them, and I want you to finish the rest, okay? And also try the one on the right there on your own. All right, the other idea is having variables on both sides. because of the equals in the way, we can't just mix this 4 and 2 and make it 6, okay? Instead, because of the equals, our goal is to eliminate all the variables from one side before we continue. And this really should be the first thing you look to do anytime you're solving one of these problems, is eliminate all the variables from one side so you can figure out and isolate the variable on the other side. In this case, I'm going to choose negative 2x. The reason for that, as you see real quickly, is when I add negative 2x to both sides, or subtract 2x from both sides, I get 2x plus 1 on the left, and I get 9 on the right. And now, since I've eliminated one of the variables from one of the sides, I can solve this problem. Now, you might be asking, well, could I have done negative 4x? And you're exactly right. You could have added negative 4x to both sides instead. Or in other words, subtracted 4x from both sides. But if you did that, and you could, that would get you the answer. If you did that, though, I would have a negative 2x on the right. And dealing with negatives just gives more room for error, more room for mistakes. So if I were you, I would recommend looking for what number to add to both sides or subtract to both sides to keep your numbers as positive as possible. So it's not essential that happens, but when solving these, it is best. Either way, if you solve it, you should get x equals 4. And let's check this. I saw in the quiz a lot of people making mistakes that if they had just checked it, would have easily overcome those mistakes. And so good idea to check. We're going to plug in our answer in for x in the original equation, and we're just going to see is the left side equal to the right side. And yes, 16 plus 1 is equal to 8 plus 9 because they're both 17, so check. All right. I'm going to show you guys the first step of this one. If I were you, I would subtract 2x from both sides. And I want you to finish that problem on your own. Now, on this next one, it's a little bit different because we have a negative 3b on the left, or minus 3b. Here, I want you to add 3b to both sides because that is going to eliminate the b from one side, and it's going to keep the number positive. Once again, you could subtract 7b from both sides, but more negatives, more room for error. Keeping it positive makes it less likely we're going to make a mistake. So go ahead and finish that one as well. And lastly, I want you to try that last one there on the right on your own and do that right now. Thank you guys for watching and have a good day.